Welcome to the Math Record. Today we'll be covering the CCML Algebra 1 contest for 2016-2017 Division A. Okay, question 1. Solve for y. Negative 4y plus 7 is greater than 6. So, negative 4 is greater than negative 1. Subtract 7 from both sides and then divide by negative 4. So, if you divide by a negative, you have to switch signs, so it's less than 1/4. So, y is less than 1/4. Okay. Question 2. Solve for q. 16 is equal to absolute value 2q minus 7. So usually how I do this is just you write 16 is equal to 2q minus 7. Actually, let's move this more to the right. 16 is equal to 2q minus 7. And the other one would be negative 16 is equal to 2q minus 7. And then solve first one, so add a 7 to that side, you get 23 is equal to 2q. Divide by 2, you get 11.5. For this one, add 7, you get negative 9 is equal to 2q. So q is equal to negative 4.5 is equal to q. So the answer is 11.5 or negative 4.5. Number 3, if f of x is equal to 2x minus 7 and g of x is 0.5x plus 3.5, calculate g of 27. So I'll put 27 into g first. So 27 times, let's just distribute out the 0.5. That gets x plus 7. So add the 27 to that, that's 34, and then multiply by half. Half of that is 17. So f of 17 is equal to, plug it in, that's 34, minus 7 is equal to 27. So the answer for number 3 is 27. Number 4, solve for g. Negative 3 absolute value of g minus 2 is less than or equal to negative 7. So divide by negative 3 first, so absolute value of g minus 2 is, since it's negative, you gotta change sides, is greater than or equal to 7 over 3. So basically, as I said before, like you're gonna have a negative and a positive. So in a way, what you're gonna really be doing is that you're just gonna have a less than or equal to negative 7 over 3 of g. Actually, sorry. Oops. You're gonna have, let's just solve this first. So then you're gonna have, thinking of this like as an equation instead of inequality. So you have a g minus 2 is equal to 7 over 3. Or you have g minus 2 is equal to negative 7 over 3. So then you have g is equal to, that's 6. So that's 13 over 3. And then g over here at 2, that's 6. So that's negative 1/3. So if you kind of think about like some amount, let's say you have to think about a number line, right? So you have negative 1/3, then you have a 13 over 3, and you have a 0 right here. So there's kind of like 3 parts. So negative infinity to negative 1 over 3, negative 1 over 3 to 13 over 3, then 13 over 3 to infinity. So basically, if you plug in 0, we plug in 0 in here, that's negative 2, which is 2. So is 2 greater than 7 over 3, which is not, so that doesn't work. So technically, there's only 2 possible answer ever. It's either in between those 2 numbers, or it's going to be outside those 2 numbers. So in this case, since you already plug in the point x is equal to 0, which is in between those numbers, and is not in that answer, that means this section does not work. So it has to be outside. So the answer has to be, let's get this out. Remember those. Has, what's q? Q has to be less than or equal to negative 1/3. And q, or Q has to be greater than or equal to 13 over 3, because those were the two numbers. So it has to be greater than the positive number or less than or equal to negative, greater than or equal to 13, the positive number, or less than or equal to the negative number. So it's going to be, when you have a number line, you do the answer, you have those 2 points, it's going to be like anywhere else above it and below it. That's basically like a simple solution how you do it. Question 5. If f of x is equal to 4x plus 5 and f of 2 plus fk is equal to 3, solve for k. So let's just plug this in. So you have f2 plus f of k. You already have f of k, so yes, fx plus 5 is equal to 3. So that's f of 4x plus 7 is equal to 3. And you plug in 4x plus 7 into f of x. So you get 16x squared plus that's 28 plus 33 is equal to 3. So yeah, 16x squared is equal to negative 30. So x is equal to negative 15 all over 8. X squared, I mean. So oops, sorry. We have, so we had to plug it into this as x. So that's 16x plus 28, 33. Yeah, 33 is equal to 3. So I don't know why I put x squared there. 16x is equal to negative 30. So x is equal to negative 15 over 8. So your answer is negative 15 over 8. Okay. Question 6. If 3x minus 5y is equal to 11 and 7x plus 3y is equal to 8, determine the value of 4x plus 8y. So we could solve for x and y first. So 3x minus 5y is equal to 11. And yes, 7x plus 3y is equal to 8. So multiply the first equation by 3 and the second equation by 5. So you get 9x minus 15y is equal to 33. And you get 35x plus 15y is equal to 40. Adding them together, you get 44x is equal to 73. Is that true? Yep. So x is, let's just move this up a little bit. Okay. We have x is equal to 73 all over 44. So plugging that back into like 3x minus 5y is equal to 11. That gets us, let's say 3 times this is 219 over 44. That's minus 11 divided by 5 to equals y, basically. So subtracting that, let's multiply by 11, so that's 219 minus anything multiplied by 11 is basically whatever the 2-digit is, just put 4 and 4 on the other side. 4 and 4, like the 2 digits that make up the 44. And then basically add those numbers together to make the middle number, which is 488. So you minus those numbers. That's basically a trick for doing multiplying by 11. And subtracting that, you basically get a 5, a 3, 14, oops, sorry. We have a 5, and a 6, and a 2. So negative 265 over 44. So let's kind of delete that. So negative 265 over 44. 265 over 44 is this top portion. And now we could divide by 5. So 216 divided by 5, you have 5, which is 25, so 3. So we have negative 53 over 44. So y is negative 53 over 44. So y is negative 53 over 44. So 4x plus 8y, multiplying this by 4, which gets us 280, and that's 12. So that's 292. And then 8 times this is negative 424. 424 all over 44. So subtracting that out, that's 2, that's 3, and that's 1, which is divided by 44. So number 6 is equivalent to no, negative 300. Negative 132 divided by 44 is equal to negative 3. Sorry about the messy work, but basically that's how you do it. I'm guessing like the easier way is like if like you combine the two equations together and somehow get 4x plus 8y, or it simplifies to that. But this way is the way that I'll usually do it, because you just get the x and the y and you know for sure it's gonna be the answer. Elena is paddling her question 7. Elena is paddling her canoe on a river. When she travels with the current, she takes 48 minutes to travel 3 miles. Traveling against the current, she takes 1 hour and 24 minutes for the return trip. If in the miles per hour, how fast is the river flowing? Okay, so we're just gonna have E, which is gonna be Elena's speed, right? And we're gonna have W as the water speed. Okay, because you have to take into account for both of them. So if she's traveling with the current, right? So Elena's speed plus the water speed, right? It takes her 48 minutes. So let's say it's per hour. Each of them is per hour. So it's gonna be like x miles per hour, and water is gonna be y miles per hour. Basically, then it's gonna be E plus W times 40 out of 60, because that's the amount of hours. Because it's in minutes. Is equal to 3 miles. And traveling against the current, right? So it's her speed minus the water speed. She takes 1 hour and 24 minutes, which is just 60 plus 24 divided by 60 minutes for the return trip. So since she went 3 miles up, she's just going 3 miles back. So it's just also 3. So basically, we just need to solve for basically how fast is the river flowing, which is basically just the water. So we have to solve for W. So using this, let's kind of simplify the equation first. So 44 divided by 60, that is divided by 12 is 4, divided by 12 is 5, so it's 4 over 5. So 4 over 5, so E plus W is equal to times 5 over 4 for the other side, so you get 15 over 4. And you have E minus W. This is 84 over 60, right? So that's 84. So divide by 4 here, that's 21. Divide by 4 here is 15. Divide by 3 is 7. Divide by 3 is 5. So multiply by 5 all over 7, that's 15 over 7. Okay. And now we just need to solve for W, basically. So an easy way to do this is basically you just you just want a negative E on one side and positive E on the other. So multiply the second equation by negative. So it'll be negative E plus W is equal to negative 17 over 7. So when they add them together, you get 2W is equal to 15 over 4 plus 15 over negative 15 minus 15 over 7. So that is that's 70, that's 35, so that's 105, that's minus 60, so that's 45 all over 28. So this is equal to 45 over 28. And then you basically divide by 2 to get W, so you have 45 over 50, all over 56 is your speed, which is basically 45 divided by 56 miles per hour. That's the speed of the current. Okay, number 8. A line with slope of m is equal to 0.7 base 7, 0.1 base 7 passes through the point 13 base 7 and 15 base 7. State the x value of the x-intercept. Leave your answer in base 7. Okay, so first you just want to convert everything to base 10. So how it basically works is that let's just say you have like 1, 2, 3, 4.5. That's a point, so it's a decimal. 6, 7, base 7, actually. 6, 7, base 7, right? Base 7. Basically, how this works is that to make it, you just gotta basically add digits in between. So this is 1, 2, 3, 4. So this is the fourth place. So that's 7 to the fourth, then 7 to the third, then 7 to the second, then 7 to the first, 7 to the -1. Because the decimal place, just think about it, is 7 to the 0. And then you have, oops, sorry. No. The 1 is 7 to the third, the 2 is 7 to the second, and then 7 to the first, and then 7 to the 0. Sorry about that. And then this would be just a decimal point, so this would be 7 -1 and 7 -2. So it will be 7 to the third times 1, 7 to the second times 2, 7 to the first times 3, 7 to the 0 times 4, 7 to the -1 times 5, and 7 to the -2 times 6. And then you add all those numbers, whatever the result is, and then you basically get the base 10 version. So that's basically like the way to do it. So the slope point 1 base 7 is basically just 7 to the -1 times 1, which is just 1 over 7th. So the slope is 1 over 7th. So 13 base 7th, that's just 7 plus 3, which is 10. So the x value is 10. And 15 base 7 is just 7 plus 5, which is just 12. So they go through point 10, 12. So basically y is equal to 1/7 x times, put the 10 in here, that's 10 over 7, because it goes to 10, 12. So 12, what here would be 84. So we need 84 on the top, since it's already 10 on the top, so we need 74 on the top. So 10 plus 74 is 84, which divides to 12. So what is the x value? The x value is just x is equal to -74, right? So basically -74. So let's take this out. Okay. So -74. Now we just need to convert this to base 7. So basically, the idea is that you're gonna raise 7, the whatever the base you want, to some power that's basically less than this number. Actually, just ignore the negative for now, because you're basically just gonna work with the positive. So 74. Basically, what power is raised to x? That's the lowest amount of x that's less than 74, which is just 2. 7 raised to a 2, which is 49. But 7 to a 3 is like 343, which is too big. So 7 to the second is 49. So remember how it's like 1, 2, 3 base 7, and 7 to the like 2, 7 to the 1, and then 7, right? 1, then 7 to 0. Basically, and you multiply and then you add them all together. Well, now you're going to do the reverse, basically. So now you have 49. How many times can 49 go to 71? Only one time. So the coefficient for 7 to 2 is basically 1. So 74 minus 49, that gets you 25. So you have 25 remaining over. So usually that's how I write it. 7 squared is equal to 1 is equal to 25. So you have 25 remaining over. So 7 to the first, that's 7. How many times can 7 go? Because this guy had to go down from 7 to... So if it's still 7 to a 3, it's 7 to a 3, then 7 to a square, 7 to a 1, and then 7 to a 0. And then it has decimal 7 to the -1, 7 to -2, etc. basically. Or 7 to a 0. I forgot about that one. So 7 to a 1, how many times can 7 to a 1 go to 25? That could go to it 3 times, which is 21. So 25 minus 21 is 4. And 7 to 0 is just basically 1. So 1 times anything is basically just like anything. So usually when there's a 7 to 0, you just have whatever is left over. So it's just 4. So that will make it 0. Because 4 minus 4 is 0. So your digit is 134 base 7, which works because that's 7 to the square, that's 49. 7 times 3 is 21, and that's just 4. So that's 74. Now, to make sure it's -74, don't forget that. You just put a negative in front of it. So you get negative 134 base 7. That's basically how you do it. Okay, so that was number 8. Number 9, solve for the order pair x, y. So, in this case, since I already have an x on the first one and 3x on the other one, let's just multiply the first equation by -3. So that's -3x minus 21y is equal to -12. and 3x minus 4y is equal to negative 13. Now you have, now you add them together, so you have negative 25. Y is equal to negative 25. So y is equal to just 1, basically. So if y is equal to 1, let's plug it into one of the original equations because they're just small enough. So I'll plug in 1 into like the first one. So x plus 7 is equal to 4, so x is equal to negative 3. So the answer for number 9 is just negative 3, 1. Basically just that simple. Question 10. Peter's current age is 10 years less than twice Greg's current age. In 7 years, 3 times Peter's age will be 1 less than 4 times Greg's age. So what is Peter's current age? So Peter's current age, let's call that P, is 2 years less than twice Greg's age. So adding 2 years to him, because it's less than 2 years, than twice Greg's age. So in 7 years, 3 times Peter's age, so PH plus 7, because in 7 years, and then 3 times of that, because it's 3 times, would be 1 less. So it has to add plus 1, is 4 times Greg's age. So Greg's age in 4 years, so 4 times Greg plus 7, basically. That's G plus 7. Sorry about that. So, let's distribute that out. That's 3p, that's 21, that's 22, is equal to 4g plus 28. I set right here that 2g is p plus 7, so substitute that in. So 3p plus 22 is equal to 2p, that's plus 4. 28 plus 4 is 32. So minus that, so Peter's age is equal to 10. So the answer for number 10 is just 10. Number 11. If 2x plus 5y is equal to 13 is perpendicular to ax plus by is equal to 6, where a and b are integers, describe the smallest possible value of a and b. So a neat trick to do this, basically, to get a perpendicular line, is that whatever the two number is in front of the original equation, basically what you're gonna do is that you're gonna switch them, and then you're gonna negative the one in front of the y. So since so now instead of 2x plus 5y, it's gonna be 5x minus 2y. So you switch the 2 and the 5, and you put it as negative 2, so negative in front of the y. It's equal to basically like any value, because then it's gonna be perpendicular. So it doesn't matter. It's just gonna be some kind of a value. So determine the smallest possible value of a plus b. So this is if you the reason they ask this question is basically they want to test your knowledge, like can you do variables. So it's gonna have to be a 5 and a negative 2. So it's gonna be some kind of multiple like that. So it's gonna be a 5a multiple and negative 2a, right? So then if this is like, let's say a is 2, so it's 10 and negative 4. It just simplifies to 5 and negative 2. And that's what we always want. We always want 5 and negative 2. So if you add them together, that gets 3a, absolute value, because that's what they said, a plus b, absolute value. So if you keep increasing a or decreasing a, you're just going to be basically increasing number, because it's going to be absolute value, so it's going to be positive. So the smallest possible value where a cannot be 0, because a is 0, then both of them are 0. A has to be like an integer, so it's like 1, 2, 3, not instead of 0. Or it's going to be, and it can't be a decimal, because they said for where a and b are integers. So the smallest possible value would be when a is either 1 or it's going to be negative 1, which is basically the same case. It's just going to be answers 3. The answer for number 11 is just 3. So whatever whatever you have for like 11, just basically just switch the x and the y coefficients and make the y coefficient negative, the negative version of itself, and then basically just add them together. Those are like that's the smallest possible value. Number 12, solve for k. So a way that I usually do this is basically you're gonna work from basically inside out. So so you're gonna work inside the absolute value, and then you're gonna do everything outside. So basically you're gonna have a negative k plus 7. Let's just leave that first because we want to work with the other side. K plus 7 plus 13 is equal to k minus 3. So just imagine there's no absolute value. Because imagine this was a positive number, so the positive does nothing. And now imagine it was a negative number, right? So plus 13. So if k minus 3 was a negative number, then you have to multiply by negative. So you have negative k plus 3. So you're going to so instead of, so that's how you're going to deal with it. So basically, from now, you're going to basically simplify. So you have negative, actually, k plus 7, right? Absolute value is equal to k minus 3 minus 16. So it's k minus 16. And then you have negative k, basically. So that's minus 16, so that's plus 16. Right? So that's your first equation. And then the next one, which is k plus 7. So negative k plus 3 minus negative 13 is negative k minus 10. Multiplied by negative 1, you basically have k plus 10. Right? So those are your two equations. So now we're basically going to do the same process again. So we have k plus 7. Imagine that it was just positive, so k plus 7 was positive, so you just delete that. So you have this. Or you have the negative version, so you have negative k minus 7 is equal to negative k plus 16. And we don't need this one anyway. Now let's get the two equations for this. So if there's one absolute value, there's two possible answers, at most two possible. And if there's two of them, it's gonna be like four possible answers. And if there's three of them, three absolute values, like at three different places, then there's 8 possible values. Outside, if they're like absolute value and absolute value, then it's a little bit more complicated. So we have k plus 7 again is equal to k plus 10. And we have k plus negative k minus 7, right? And you have k plus 10. So those are our four equations that we had to work with. So about writing it diagonally, my tablet's strange. So k plus 7 and negative k plus 7, negative k plus 16, that's 2k is equal to 9. So k is equal to 4.5. Negative k minus 7 and negative k plus 16. No matter what way, it's going to be not equal to each other, because if you add k to both sides, it's negative 16 is equal to negative 7 is equal to 16, which is not true. So you can't do anything about this, so this thing is not possible. Same case here. K plus 7 is equal to k plus 10. If you minus k from both sides, 7 is equal to 10, which is not true. And you have negative k minus 7 is equal to k plus 10. So basically you have 2k, right? Minus 7 to minus 10 to the other side, so you have negative 7. And now you have negative 17 divided by 2, which is negative 8.5. So k is negative 8.5. So those are your two answers, 4.5 and negative 8.5. You can plug them in to check your answers, but usually they're true. Sometimes I usually do plug it in just to check that I'm right. Question 13. How many three different numbers? This means the leading digit cannot be 0, contains a 3, 5, or both 3 and 5. So basically, they're just asking for how many numbers are there that has a 3 or a 5 in or like just multiples of them. So instead of like finding 3s or 5 or multiples of them, that seems like a lot of work because you have to specify. Let's take away all the numbers that are not, which is easier to think about. So how many ways for 3-digit numbers can you put in the first number? You can put anything from 0 to not from 1 to 9, so there's 9 ways. X for the second number is 0 to 10, so there's 10 ways. 0 to 9, which is 10 ways. And the third number is also 0 to 9, which is also 10 ways. So how many ways can you put for the first number? For like when you cannot have a 0 or a 3 or a 5, that's 10 ways. And how many ways can you put for the second number that's not 3 or 5? Now you can have 0, so there's only 8. In this same case, 8. So multiplying that out, that's 900. 8 times 8 is 64, times 7. That's 714, and that's 28. 714, 21. So that's 42, and that's 21, 42, and 44. So that's 448. Okay. So subtracting those out, that's a 2, that's a 5, and that's a 4. So the answer is 452. Madeline has some quarters and dollar coins. For a quarter and dollar coins for a total of 13 coins. So we have quarters plus dollars is equal to 13. Madeline initially found the total value of coins to be $7.75. So she has. Let's just put that into like hundreds. So we have 775 basically. So basically, quarters, which is basically 25, and 75, and dollars are basically 100 coins basically, which equals to 775. Okay, and then she then realized she categorized two of the coins wrong basically. So what is the positive difference between the maximum and minimum possible value of the coins? So we have to solve this. So divide by 25. So that's D. So that's 4, that's 28, and that's 31. Okay. So using that, we have negative Q minus D is equal to negative 13. Multiply the first equation by negative 1. And that gets 3D is equal to 18. So D is equal to 6. So Q is equal to 7. So let's say the two difference, because the maximum value would be like if you change all of like the the quarters into basically dollars. So basically, if two of the ones are different, let's say two of the quarters were basically dimes, that will give us the maximum value. So the maximum value would be $8 and 5 quarters, and the minimum value would be like if the dollars turn into quarters. So we will have $4 and we have 9 quarters. So this would be $8, and this would be $1.25. So this would be $9.25. This would be $4. This would be $4, and this would be $2.25. So this would be $6.25. So tracking them, you get 3. So the answer for number 14 is 3. Okay. And delete. Okay. Question 15. Solve for x. Point 1, 2 repeating. Okay, let's just gonna. Well, why I usually refer to these concepts is basically repeating decimals. So we had to make these decimals into fractions. So to do this, let's say a is equal to 0.1.12 repeating, right? Multiply this by 100. A. So you basically move the decimal place. So it's multiplied by 10, 100, 1,000, etc. So you multiply 100, you move 2 decimal places, so it's 1, 2, and it's repeating again. So subtracting that, basically get 99x, 100 minus A, 100A minus A, and then 12.12 repeating, repeated by 1, 2 repeating, just gets 12. You see how that worked? So you get 12 over 99. So you're basically gonna do that for like the rest of the repeating. So you have 12 over 99. Let's write that down. X minus 19. So that's A is 0.019 repeating. Multiplied by 100A. So it has 1, 2, 1.919 repeating. So subtracting that, that's 1.9 over 99. Multiplied by 10, so 19 over 990. So it's 19 over 990. Right? Minus 19 over 990. I'm seeing that this is 19 repeating and there's 19 on top. So I'm guessing the 57 repeating is just 57 over 990. You could do the math on it too, but I think it's pretty safe to say it's right. So you have 12 divided by 99x. Add 19 over 990 to both sides. So that's 5, 6, 76 all over 990. And multiplying by 99 divided by 12. That's a 10. Divide by 2, that's 38. Divide by 2, that's 5. 6. Divide by 2, that's 19. Divide by 2, that's 5. So that's 19 all over 30. So x is greater than 19 over 30. That's the answer. So the answer for number 5 would be that. I mean number 15, not number 5. Number 6, determine the value of the order triple x, y, z that is the solution to 2x plus y plus 7. Okay, basically this on the side. I'm not gonna say that out. So, since I already see that like the 7, I mean the z is already singular by itself, I'm just gonna cancel out the z first, and then I'm gonna get x and y, and then I'm gonna cancel out one of the other variables to get the last variable. So, adding the first and the second equation, you get 6x. Oops. Okay. So you get 6x plus 3y is equal to 21. And the first equation subtracted by the second equation, so you get 2x minus 2x, y minus negative y is 2y, and z minus z is 0. So 5 minus 3 is 2. So y is equal to 1. So I already got 1. So that means x has to equal, so that's 3, that's 18, that's 3. So we already got x and y. So plugging in back for z, you already have 3, 1. So that's 6, and that's 1, that's 7. So 5 minus 7 is negative 2. So the answer is 3, 1, negative 2. Basically just that simple. Question 17. If f of 3x minus 4 is equal to x minus 2, find f of 3. So you want to somehow get 3x minus 4 is equal to 3. So 3x is equal to 7, so x is 7 over 3. So when f is put in 7 over 3, that puts 3x minus 4, so f of 3 would equal to 7 over 3 minus 2. So that's 6 over 3, so that's 1/3. So f of 3 is just 1/3. That's the answer. Question 18, solve for x. X plus 2 plus x minus 2 is equal to 4. So same case as how I did for 12, we're just going to split into parts. So we're going to have x plus 2 plus, let's say it's just positive, so just x minus 2 is equal to 4. Or you have x plus 2, absolute value, and then you have the negative versions of those, so it's negative x plus 2, which is equal to 4. So that gets x plus 2. Simplifying the first one, you get is equal to negative x, and then plus 6. And you have x plus 2, absolute value, and you have x plus 2. Okay, move this up. So using that, the first equation, x plus 2 is equal to negative x plus 6. And you have negative x plus negative x minus 2. Sorry about that. Is equal to x negative x plus 6. Or you have the second equation, which is x plus 2, which is equal to x plus 2. And you have negative x minus 2 is equal to x plus 2. So first equation, you get 2x, and that's going to be 4. So x is equal to 2. So x is equal to 2 as the first solution. And negative x minus 2 and negative x plus 6. There's no solution for this one, so this one doesn't work. This one has infinite solutions. So x is equal to infinite. We're just going to have to test points to see if it's true, basically. And then negative x minus 2 and x plus 2. That's 2x, that's negative 4, so x is just 2. Wait. 2x and negative 4, so that's negative 2. Negative 2. So we're just gonna plug in these values to see if it's true. So if x is equal to 2, that's 4, and that's 0, so that's true. So negative 2, that's negative 4, that's 0, and then negative 4, that's 4, that's true. Now let's just plug in any random value because this says this is infinite. So if it doesn't work, then infinite is not an answer. So we're gonna have 1, so that's 3, and that's -1, so that's 4. Okay, let's plug another one. That's 2 and -2. Let's play x is equal to 0. That's 2, and that's -2, and that's 4. So based on this, it's let's actually choose something else. Let's say like 3. So that's 5, and that's -1. Um, that also doesn't work. 5, no, 5 and -1, that makes 6, so that doesn't work. So basically, when I was choosing numbers in between 2 and -2, and they give me the infinite sign, what I was basically doing is that I'm seeing a trend where if it was -2 or 2, that all the numbers between it, when you adding them together, like kind of just gets basically the right number. Because if you think about it, if you see this equation, if you put the numbers in between, then those numbers kind of like, since one is uh bigger than because because the number is between -2 and 2, that means one number is going to become the negative version away from the 2, and one is going to be the positive, and that distance between them is always just going to be 2. So it's just going to be 2 all the time. So from 2 away and 2 away, and that gets 4. That's going to be 4. So my answer for number 18, since it works for -2 to 2 and all those numbers in between, basically it's just -2 is less than or equal to x is less than or equal to 2. So it's got to be between these groups of numbers, basically. Question 19. A flag has 3 vertical stripes, and a stripe can be one of 5 colors: red, blue, green, purple, and yellow. A logo can be stitched across the flag so that a red, blue, green flag is not the same as a green, blue, red flag. So permutations are the same, are not the same. So we're using permutations. So like a RGB is not the same thing as a G, BGR. So blue, red, green, as I saying. I'm just using that scale. If stripes that cannot be the same color and at least one of the stripes must be green, how many different flags are there? So it's only gonna be either 1 green or 2 greens. You can't have 3 greens because then it's 3 vertical stripes, and basically they're gonna be touching, so it's not gonna work. So it's 1 green and 2 greens. So 1 green, you have 1 green. Let's see, you have 3 different colors, right? You have a green here. So you can have 4 different colors on the first one, and because there's 5 colors, right? So 5 minus 1 is 4. And you can only have 3 for the second one, because let's say if this is red, you can't have red again, okay? Because they cannot be touching the same color. So you have a green right here. You got 4 here and 4 here, because technically those are not touching and those are not green, so technically it's gonna work. And if you have 1 here, it's the same case, but this is 4 and now this is 3. Okay. So that gets 12, that gets 16, and this gets 12. So that is a. Let's just do, like, if there's 2 greens, the greens can only be in the first one and the third one, but you can't put in the second, because you put in the second, they're gonna be touching each other. So the other color in the middle could be 4, because you can't have green. So this is 4. So adding that together, we have that's 28. This is 16, so 28 plus 16 is 44. So the answer for number 19 is 44. Basically just that simple. Number 20. If y plus x is equal to 5, and y is greater than -3, solve for y. Okay, whenever they give questions like these, where you do something like y is x, I mean absolute value of y plus absolute value of x is equal to, like, basically a number. So like, let's say a, or you have some coefficients or something. Um, Basically what I usually do is that I kind of draw a graph. Usually when they do this, they ask for area question is less than or equal. It's usually just less than. Less than, or yeah, it's either less than or equal to, or just less than. What you usually do is that you're gonna draw a graph that looks kind of like a diamond. And this is just from personal experience. So basically, if you have y, let's say a is equal, like, the 5, right? Then basically it should just be 5 on top. Oops. 5 on top and negative 5 on the bottom. Because if it's 0, right? And then you have 5 on the right and then negative 5 here. And basically, you're just going to have because it's going to be negative or positive. If you think about how we solve question 18 and question 12, you're just basically changing the slope. So you're basically changing it like here, negative or positive, like up here, and then down here, and then down here, and then up here. I mean, down here also. So basically, that's what what it's making. It's making like some kind of diamond. And there's 5, right? So if they say x is greater than -3, solve for y. So x has to be like let's say right here is -3, right? So it's gonna be any number basically here. But so we just had to find the range because they say solve for y because it could be a bunch of numbers. So the highest point is right here and the lowest point is right here, which is just 5 to -5. So the answer is just 5 is less than or equal to y is less than or equal to -5 is less than or equal to y is less than or equal to 5. So that's the answer. It's a pretty cool question, but whenever they usually the question when they ask for these is when they're trying to ask for the area that's constricted by this with absolute values. Usually the answer would just be whatever that is squared divided by 2. So it'll be 5 squared divided by 2, so it'll be 12.5. Usually that's the question, but this is a cool interpretation too. So that basically covers everything for the CCML Algebra 1 Contest for 2016-2017 Division A. Thanks for watching, and I'll see you at the next math record.